All right, so what was your reading talking about, Emily?
Putting functions into table form.
Putting functions, linear functions more specifically, into table form. What are linear functions? What are linear functions? Yes, Lila.
Function makes a straight line.
Good. Function makes a straight line. Anything else? Yes.
To the first degree.
To the first degree. Good. Something else?
Every input only has one output.
That's a function. We're talking specifically to linear. Area has a constant rate of change. Good. I don't know where you guys are getting this stuff from, but that's good. Okay. Anything else that we've been talking about with linear functions that's important? Anything else we've been talking about? Yes. Y equals mx plus b. What's that called? Slope-intercept form. Okay, slope-intercept form. Now, in this section, in 2.3, it's talking about, hey, we're going to be looking at tables of linear functions and trying to compare those. Well, again, for the third time in a row, what are the important things that we're looking for? Just now we're looking and trying to find them out of a table. Initial value and rate of change. I mean, seriously, like we should be tired of hearing about those two things, right? Initial value and rate of change. That's what linear functions are all about because they have a constant rate of change. And then the initial value is when our input is 0, or another name for initial value? Y-intercept. Okay, the Y-intercept. So you've read it. You've highlighted it. I'm going to go through some examples. I'm not giving you a sheet like I did yesterday. So you need to write these examples down. Okay? You need to write these examples down. As you can tell, I'm recording it, so if you miss something, if I go a little bit too fast, I'll post this on your Google Classroom, and you'll be able to go back and pick up anything that you miss when you're studying or reviewing. Okay? I do plan to go a little bit quick today. I'm going to try to get done in 10 or 11 minutes. Okay? That's my goal. We'll see how we do. Example 1. Create a table for the cost, C, for a ticket to a movie is determined by the following equation. Okay, so they already give us our equation. That's wonderful. And I want to be able to complete this table. All right? It looks like hold on, timeout. There it is. It looks like, when it goes from 10 to 12, there's several things I can do to determine what I want here or what I want to do. What are some of the things I can do? You just read about it. Could. Blessing? We could. Zyler? I got to put in some appropriate inputs. But in this case, I'm already given some information. Okay? Without any information, I can just try to choose appropriate inputs where, if it's a fraction, I'd use the denominator. If it was a square root, I'd use, but we're not talking about any of those. I have part of it. I have the equation. So since I have the equation, how about I start right here at 10, and I just plug that in. C equals 9 times 10 plus 7. Well, 9 times 10 is plus 7 is 97. Then I can turn around and do the same thing for 12. 9 times 12. 9 times 12. All right. I don't know how you guys do it in your head. I like to break things apart when it gets to double digits. 9 times 10 is 90. 9 times 2, 18, and 90 is 108. If you don't already know that 9 times 12 is 108. So 108 plus 7, 115. 115. All right, so that was how I did the first two, what I knew the input. What do I do when I know the output, Zyler?
Plug the output in for C.
Yeah, I plug the output in for C. So 88 equals 9t plus 7. So now what?
You subtract 7.
Subtract 7 from both sides. Whatever I do to one side, got to do the other. So 81 equals 9t. Now what?
Divide by 9.
Divide by 9. 81 divided by 9 is 9 equals t. Now, I could turn around and keep doing the same thing, or I could now start to see some patterns. Do you see some patterns?
Yeah.
Me too. So what do you think goes above 106?
11,
And
13, 13.
so I can use my brain. I don't just have to use the math portion. Okay, I can use the logic and deduction and things like that. Any question on example 1? Okay, I'll try to keep that on the screen if possible. Example 2, create a table for a situation where there is 1 dodgeball for every 3 players with 2 extra dodgeballs on the sideline. There is 1 dodgeball for every 3 players. So that's 1. What's the rate of change here? 1 over 3. 1 over 3. So there's 1 for every 3. There's 1 ball for every 3 players. Oops, not B, P. Sorry. 1/3 P plus 2 extra. That's our initial value, right? And that equals how many balls we have. All right, cool. Now I need to fill in this chart. What am I going to do?
Take the denominator.
I got to use the denominator. I got to choose those appropriate inputs, right? So 0, 3, 6, 9, and 12. We all understand why I chose those numbers, right? They are multiples of the denominator. Otherwise, I'm going to get fractions and decimals, and we don't like those. Well, 0 is easy, isn't it? 2. All right, so now we plug in. B equals 1/3 times 3 plus 2. Well, 1/3 times 3 is 1, plus 2 is 3. Do you see the pattern already? What's the next number going to be? So we don't really have to do that much computation because we can see the pattern as well. And it's nice when it's linear because it's a constant rate of change, so we know that pattern is going to hold true. Cool on example 2? For shoe? All right. Sorry, I'm not going to be able to keep that one totally on the screen for you. Get a little smaller. How about that? Is that okay? It's too small to see?
Nope.
All right. Now we're going to create a table that shows the money paid over time. Watch this. I think this is so cool. I think people miss this all the time. We talked about it a little bit yesterday. Look at these lattice points. There's one, there's one, there's one, there's one, so on. Everybody see those lattice points? Well, there's a lot of them on this one. This first lattice point, what is it? What's its value? This is a 1, right? And this is a 200. So what's that ordered pair? 1, 200. What's the next one? 2, 250. The next one, 3, 300. Do you see the pattern? Anybody? Next one. Boy, that was like stealing. Right? That was easy. Stealing candy from a baby, yeah? Everybody acts like that's easy, but it's really not. Stealing candy from a baby, they start crying, their mama starts hitting you. It's not really that easy. It is not Bullying. We got to work on our definition of bullying. So your definition of bullying is taking something from a child.
No, but
That's what I said. We got to work on our definition. Number 4, create an equation. What are the things that we need to know so that we can create an equation? Rate of change in initial value. Thank you very much. Rate of change in initial value. So let's find our rate of change. We usually do this really quick. This is 5, 5, 5, 5. What is that? Our rise or our run? It's our run. Then what's our rise? 10, 10, 10, 10. That's our rise. What is slope? Oops. Rise over run. 10 over 5 is 2. Well, that was easy. Yes. How do I find my initial value? Backtrack. Let's backtrack. My next one would be 5 and 15, and then 0 and 5. There it is. Backtrack, no problem. So my rate of change is 2. My initial value is 5. So my equation is C equals 2t plus 5. Sorry, my t's and my pluses look alike. How we doing? Let's create equation again. Go as fast as you can. Good luck. How many people got it? Oh, I go too fast. My bad. Notice that I quickly found my run was going up 20 every time. My rise was going up 15 every time. So my rise is 15 over my run of 20. That reduces to 3/4. 5 goes into both of those. And then I backtracked again. Went down 20, that got me to 0. Down 15, that got me a negative 10. So there I found my rise and my run. My initial value really quick. P equals 3/4 G minus 10. How many people got the same thing? Give yourselves 2. So the whole point of all of this is to be able to compare our functions, okay? And what do we have to do in order to compare them? Well, we got to be able to get them in the same format, either all in equations, all in tables, all in. If you get them all in tables, in order to compare them, you got to have the same inputs to be able to compare them as well. So I think probably the 2 easiest ways to compare functions is 1 in equation form, and then 2 in graph form. But if you're going to graph them all on the same graph, which can be difficult from time to time. So here we have a situation. You're deciding which job offer is the best to take. Here's the information about the pay, depending on the number of hours worked. Okay, so let's take all 4 of these situations now and turn them into equations. Can we do that? We need 2 things. What are they? Thank you. I thought we were not getting that yet, but we got it. So Red Lobster pays $6.50 per hour and a $25 bonus. So pay equals 6.5 H plus 25. Yes? Dick's Sporting Goods already gave us the equation. What is it?
P equals 7.5 H plus 10.
Very good. So what's better about Dick's Sporting Goods?
They give us the equation.
No, not only that, about the actual job. Pay more per hour. However, Red Lobster gives you a bigger bonus. Bigger bonus. And what's that bonus again? That bonus is, is that every day? No. It's probably per pay period. Okay. All right, let's look at Mako's market. Initial value is 20. And let's see, I got a lattice point there. Holy cow. I don't have another lattice point till way over here. All right.
One has 3.
3. I think that misses. Does it matter if I get the wrong lattice point?
Yeah.
No, it don't. As long as I get a lattice point that I'm sure of, even if I skip one, it'll still reduce. Are you with me? So if I miss that one at 3, it'll be okay because it'll reduce and I'll know it's something over 3. Okay, so let me check it. 1, 2, 3, 4, 5, 6, 7, 8. It was 8. That was my run. And then this is going up by 10s, right? 10, 20, 30, 40, 50. 50 over 8, which would be what? 25 over 4. That's it, right? I mean, it can give me a decimal, but can I just leave it like that? Well, let's go to a decimal just for fun. 4 goes into 25 how many times? With 1 left over? So 6 1/4 or 6.25. So they're going to be paying us $6.25 an hour. Are you with me? So for Mako, it's P equals 6.25 per hour plus 20. All right, last one, Walmart. Walmart, this bad boy's going up by 2, 2, 2, 2. This thing's going up by, what is that? 16, 16, 16, 16. So 16 over 2, which is 8. Can I backtrack? Sure. That's what? 6, 4, 2, 0. So 69 minus 16. Anybody? 53 minus 16. Anybody? 37 minus 16. You stupid. No, I'm not. What's that? Oh, sorry. We were just talking about that last night. 21 minus 16. 5. There's my initial value. So Walmart is P equals 8H plus 5. Which job makes the most money per hour? Walmart. Wally World. Which job has the biggest bonus? Red Lobster. How much money would you make at each job if you worked 40 hours? Which job would pay the most money? Okay. You guys. Red Lobster. You guys. Dick's Sporting Goods. You guys. Mako's. You in the back. Walmart. Quickly, go. How much?
How many hours?
40 hours. You were a 40-hour week. How much did you make? Go. You got to plug it in for hours, right? First one's got it. Speak up. Yep. $3.25 for Walmart.
310 for Dick's.
$3.10 for Dick's Sporting Goods. Red Lobster, $160. $260, sorry. $260 for Red Lobster. Waiting on Mako's. $270. 40-hour work week. Best place? Wally World. Last question. Same stores. How many hours would you have to work at each job to make $100? So what do you do with that $100? Plug it in for C. Go. As soon as you got it, let me know.
12 hours for Walmart.
For what? Walmart, 12 hours?
That's what we're doing, right?
Yep.
Oh, we're doing this.
Oh.
Sorry.
525.
For Red Lobster. Walmart and Mako. Walmart Blessing.
11.
Ooh.
12.
12 for Mako. Oh, we got, yep, okay. Still waiting on Mako. I'm sorry. 12.8. Okay, so who works the least to make $100? Red Lobster. Why? Why would they have to work the least to get to $100? No. They already have $25 in their bonus, right? Already get $25 in bonus. So there you are. Homework is even questions. 2.3C even questions. There's a quiz coming up Monday or Tuesday. Okay? You all have a great weekend.